And I'm going to share my screen also. All right, so I think we're recording. Oh, I felt bad my last class. I thought we were recording and it didn't record, so. But that was my statistics class. Okay, so we're going to start on 8.2, which is arithmetic sequences. Okay, and so the interesting thing about arithmetic sequences is the fact that they have the first term is known as A, and they all have a common difference, which we use the letter D for. Okay, so all right. Oh, we got a lot of late arrivers today. Maybe I should give 2 points for being on time and then 1 point for being late, huh? All right, so let's see here. I think you guys will like this. One of the interesting things about chapter 8 is when you're learning each one of the things, it's easy, and then it's just a little bit harder when you get into the test, and then it's like, oh, what is this, or which formula do I use? Okay, so the main formula that we're going to want to use for the arithmetic sequence is, and I wish I could do subscripts, so I'm going to do capitals and then smaller case for subscripts. So A sub n equals A plus n minus 1 times some constant d. D is your common difference. Okay, so this is going to be your most important formula that you're going to, well, one of the most important formulas that you'll want to use for this section. So in this case, let's say that I had a sequence that was 13, 7, 1, -5, and then the sequence just continues on. Okay, so what would be your common difference D equal to in this arithmetic sequence? Let's see here. Let's pick on Andrew. What do you think?
-6.
-6. I'm glad you said -6. That's good, because we're going to be subtracting 6 every time. And your first term for the really hard question, I'll let you do that one too. A would equal
13.
13. Okay. You're like, oh man, if that's how this test is, this is going to be easy, right?
Yeah.
All right. So now the question is, can you find A sub n and A sub 300? So since I picked on Andrew already, I will pick on Demi. Can you help me find A sub n and A sub 300? Or well, I'll let you do A sub n. We'll let somebody else do the 300. A sub n, what would that be?
Would it be, would you basically replace the 13 and put it into the parentheses?
Okay. What's the 13? Well, what do you mean by the parentheses?
So in the formula.
Okay, so A in the formula is
13.
13 plus
6.
Well, no, we're going to leave that as n minus 1.
Oh, okay, sorry, I can't really see the formula on there. Is that n minus 1 parentheses D?
Times D, and D in this case is?
-6.
-6, okay. And then we could simplify that. If we multiply the 13 through, we're going to get, maybe I'll just move this down. So if we distribute the -6, here, I'll try to make it a little bigger. Are you on your phone or are you on a laptop?
No, I'm on my laptop. I don't know why it's kind of small.
Okay, I made it a little bigger. Hopefully that's better.
Okay,
So
so
it's
you just distribute the 13 through there,
the 6,
or the 6,
right? So 13,
and
and
then
then
plus, is that n plus 6? So this is 10,
so n times -6 is -6n, right?
yeah,
And then -1 times -6 would be plus
6.
6. Okay. And so 13, so a sub n equals 13 plus 6 is 19, right?
19, sorry, yeah.
Minus 6n. Okay. So now we have our nice formula for for this arithmetic sequence right there. Okay. And so now that Demi has found a sub n, can somebody else, such as Hallie, can you find a sub 300?
Would that just be 19 minus 6 times 300?
Minus 6 times 300. 6 times 300 is 1800. 1800 minus 19 would be 1781, right?
Mm-hmm.
Okay. All right, so this isn't too bad, right?
Wouldn't that be a negative?
Oh, it is negative, thank you. I forgot my negative. Yep, negative 1781. Okay. All right, now how about, what if I did something that was a little bit harder this time? How about if I told you that the 11th term of an arithmetic sequence is 52 and the 19th term is 92. Find the 1000th term. Okay. So I will open this up to everyone. Do you guys have an idea on how you would figure this one out? What do you guys think?
Would you do something with finding the difference between 52 and 92 and 11 and 19? Like it's 8 terms in the middle and then do something with the number between 52 and 92? Does that make
Yeah,
any
do you think there would be any good formulas that would help us do that?
The A of n equals A plus n minus 1.
That's right. That's right. We're going to use that formula right there. So, yes, you're on the right track, Hallie. So, we know that a sub 11 equals 52, right?
Yeah.
And of course, we can plug in our formula, and we don't know our first term, right? So we'll leave that as a plus. Well, if n is 11, what's n minus 1?
10.
10 times, we don't know our common difference, d, right? Okay, so we'll leave that alone. Okay, and we also know that a sub 19 equals 92, right?
Mm-hmm.
And so we can plug that into our formula, into our great formula here. And that's going to be a plus, this is going to be 19 minus 1, which is going to be 18d, right?
Mm-hmm.
So now, 2 equations and 2 unknowns. How can we solve that?
Elimination.
Elimination, thank you. I thought somebody was going to say matrices because they love that so much, but we can do elimination. All right, so 52 minus 92 is negative 40. The a's eliminate. A minus a is 0, and then I'm going to get 10 minus 18 is negative 8d. I think I need to put an apostrophe there. It's going to get mad at me. Okay. Now we can divide both sides by negative 8, right? Negative 8. And therefore, d is going to equal 5, right? Okay. And if d equals 5, we can plug it into either equation, right? Which equation? Let's see, whose turn is it now? It must be Joey's turn. Joey, which equation should I plug the d equals 5 into?
Can you hear me?
Very faintly, I could hear you.
Let me try my headphones again.
Okay. Speak extra loud.
Well, can you hear me now?
Oh, that's much better.
Hopefully they stay in.
You got soft again.
The heck? What was the question again? Sorry.
So I've got d equals 5 here. And I need to put it into one of those two equations to find a, right? So which one should I plug it into?
Let's do the A11.
Okay.
That'd be
So 52 equals
A plus 50.
plus 10 times 5, which is 50. Okay.
Mhm. So then you
So I
minus
can subtract
50.
50 from both sides.
A equals 2.
So therefore, a equals 2. Okay. All right. So I've got my a equals 2. I've got my d equals 50. Maybe I'll put those in, say, gray. I can plug those into my yellow equation here, and I will get what? A sub n equals
Let's do 2 plus
2 plus
n.
n
Or wait.
minus 1
Yeah, n minus 1 times,
Times
5.
5. Okay, and I could even simplify that further. A sub n equals
5
let's
n
see.
minus 5.
So let's see, negative 5 plus 2 is going to be negative 3 plus n, right?
Yeah.
Okay. So now that I've got that, oh, it's 5n, sorry, 5n. Right? Okay, so now we'll pick on somebody else to find A1000. And the other person that we're going to pick on is Lauren. Can you help us find A1000?
Yeah, so A1000, you just plug it in for the n, so it would be negative 3 plus 5 times 1,000.
5 times 1,000. And because I can just press enter and it will tell me that's 49.97. Okay? Are you guys liking this so far?
Yeah.
Yeah, this isn't too bad. Okay? All right, so let's talk about, here I'm going to tell you guys an interesting story. Okay, we're going to talk about partial sums. Okay, so I'm going to tell you an interesting story, true story. There was a famous mathematician, but I can't remember his name. I was going to look it up between classes, but I didn't have time. And basically, he was in the 3rd grade. He was bugging his teacher. And his teacher said, go add the first 100 numbers, because she thought that would take him a long time, and tell me what the answer is. And so he came back like a minute later, and he said the answer was 50-50, which is the correct answer. Could you do that in a minute? Especially if you were in the 3rd grade?
Yeah, of course.
Of course. Okay, so there was a little bit of a trick that he used to figure that out so quickly, because his teacher was like, how did you figure that out so fast? And it was correct. Well, what he figured out was, he says, okay, well, if I take 1, the first number is going to be 1. The last number is going to be 100. And of course, when you add those up, that adds up to 101. The second number is going to be 2. The second to last number is going to be 99. And of course, if you add those together, you're going to get 101. The third number is going to be 3. The last number is going to be 98. And of course, if you add those together, you're going to get 101. Okay? So you can see that we're going to repeat this 101. The question is, how many pairs are you going to have for the first 100 numbers?
$50.
You're going to have 50. And 50 times 101 is 50. Okay? Pretty impressive for a third grader to figure that out, don't you think? Okay? So, I certainly was not that smart when I was in the third grade, but it leads into a couple of formulas that we can do. So we can take what he did, what this third grader did, and we can find the sum of an arithmetic sequence. And so I'm going to give you 2 formulas. The one that we just demonstrated, S sub n equals, basically you can take the total number that you're going to have, you're going to divide it by 2, and then so that'll give you the number of pairs, and then you're going to take the first number, a sub 1, plus the last number, a sub n. And that will give you the sum of all those. So this here is another formula that you're going to want to know for the test and for the quiz. Okay. Now the question is, what if you don't know the second number, a sub n? Well, from what we just did on this first thing, we could substitute in this formula for a sub n. And so if I do that, I'm going to just show you this really quickly. You're still going to have your n over 2. You're going to multiply that by a sub 1 plus, and now we're going to do a sub 1 plus n minus 1 times your difference d. Okay? Or simplified, we could still do that as n over 2 times 2 times a sub 1 plus n minus 1 times your difference d. Okay? Forgot to put in my first parenthesis there. So this basically is the same formula here. So basically these 2 formulas are basically the same thing. It's nice when in the third grader's case, we knew what the last number was, and we could figure out the number of pairs easily. If you don't know, you can always use the second formula. Okay, so those are basically the same formula. Okay, so let's go ahead and let's say I want you to find the sum of the first 50 odd numbers. Okay. So who can help me do that? How about Michael? Can you help me do that, Michael?
So you're finding the sum of the first 50 odd numbers.
Correct.
So there's 25 odd numbers.
Okay.
So
You've got some great music in the background.
yep, it's great. I'm not certain where you would go from there. Would you start with the first number and the last number?
Do you know what the last number is?
Oh, that's true. You don't know what the last number is. It just said the first 50 odd numbers.
Right. So you could might as well use the second equation, right?
Yes.
Okay.
So 2 times a1.
Okay, well, we need the n over 2, right? So we're using the first 50 odd
Right.
numbers. So we've got 50 in our
Uh-huh.
sequence divided by 2 times, and 2 times, what's your first odd number?
You don't know, but it's 2 times
No,
the
you know your first odd number.
first
It's 1.
50 odd numbers. Oh, so it's just the from 1 to 50. Okay.
Right. No, it's not from 1 to 50. It's 1 and 3 and 5 and 7 and 9, etc.
Yes.
So
Right.
the first
Right.
number in the sequence is 1.
Yes.
Okay. Plus, now we let's see, what's n minus 1 in this case?
N minus 1.
Uh-huh.
N minus 1.
If we're taking the first 50, what's 50 minus 1?
49.
49. And your common difference is
2.
2. Okay? So now we can do that. So we've got 25 times, and then in parentheses I've got 49 times 2 is 98 plus 2 is 100. And so 25 times 100 equals 2,500. Okay? Piece of cake? All right, now let's do another one. What if I said find the sum? Yeah.
I had a quick question. So you did 2 times 1 plus 49 times 2.
Yeah, I'm using this formula right here.
So you did 50 divided by 2 and then.
Because
So
we're taking the first 50 odd numbers, so 50 minus 1 is 49.
Right, and a of 1 is 1.
Right.
Why is your D 2?
Because we're doing odd numbers. So the difference between 1 and 3 is 2. Between 3 and 5 is 2. And 5 and 7 is 2. So your difference is 2.
Okay.
Does that make sense?
Yeah.
Okay. All right. So let's say that we want to find the partial sum of the following sequence. Okay. So the sequence is 3 plus 7, 11 plus 15 plus ... whatever that is in between, all the way until we get up to 159. Okay. So after Michael, it must be Riley's turn, I think. Riley, can you help me figure this out?
I'm not completely sure where to even start with this.
No idea?
No.
Oh, it's on the page. One of these equations will help us, right?
Do you just use the 3 and the 159?
So are you using this formula here?
Yeah.
That's a good formula to use. So you know your first and your last term, right?
Yeah.
So S sub n equals, now we don't know the n over 2 yet. We'll leave that for now. Times your first term, which is what?
3.
3 plus
159.
59. Whoops, 159. Okay, so that's 162 divided by 2. So we know that S sub n equals 162 divided by 2 is 81 times n. Now the problem is we don't know how many pairs we've got, right?
Yeah.
So how do we figure out what n is? Any ideas?
No.
Okay, does anybody have any ideas? How would we figure out what n was?
Would you go back up and use that the a sub n equals a plus n minus 1?
Was that Andrew?
Yes.
That's right. Okay. I'm getting better at knowing your voices. Okay.
Wait, why is it equal to 81n?
So I just simplified. So we were using this formula here, right? We know the first number is 3. The last number is 159. So 3 plus 159 is 162.
Right.
So 162 times 1/2 is 81.
Oh, you
So I
times
could-
it by 1/2.
I
Okay.
just multiplied it, right? Yeah. Okay. All right. So now we need to figure out. We know that a sub n is 159, right? We don't know what the n is, but we know that whatever the last number in our sequence is 159. We know the first number in our sequence is 3 plus, we don't know what n is, so I'll leave that as n minus 1. But what's your common difference in this sequence here?
4.
4. Okay. So if I simplify this, this becomes 3 plus 4n minus 4. So 3 minus 4 is -1. So if I add 1 to both sides, then I'm going to get 160 equals 4n. And then how do I solve for n? Nobody wants to say, or nobody knows?
It's going to be 159 equals 4n minus 1, and then add 1 to each side.
Yeah. So I've got 4n equals 160.
Yeah. And then
So
just
how do
divide by 4 and you'll get 40.
Divide by 4. So in this case, your n equals 40. Now I can plug it back into this equation here, and I'm going to get 81 times 40, and that equals 3,240. Okay?
Why did you add 1s to both sides?
So
Not the one.
back here, I've got 159 equals 3. So I took the 3 minus 4, which is -1. So another way to write this would be 4n minus 1. So I added 1 to get rid of the 1. Does that make sense?
No, not really.
Okay.
Because did you plug the 4 into the
Yeah,
n
so let me
minus
back
1?
up here. Let me back up here. Okay. So you followed me. So we use this equation here, and I had 159 equals a, which is your first term, 3, plus n minus 1 times d, which is 4. You can see these are all 4 apart, right? So when I distribute the 4, I'm going to get 3 plus 4n minus 4. Well, 3 minus 4 is -1 plus n, plus 4n, right?
Yeah, I got it. Okay.
So now I can add 1 to get rid of the 1, and it's 4n equals 1 there. Okay? All right. Any other questions on that? So my sum here was 3,240. Now, let me just say something about this. It seems like, well, I know for a fact at Salt Lake Community College, they love to put questions like this on the final exam. And so the way some people do it is they actually list, in this case, all 40 terms, and they add them up. And you will, if you do that, you will get 3,240. You will also run out of time. Okay? So what I would encourage you guys to do is make sure you know these formulas really well, because if you want to list out all 40 terms, yeah, you'll probably get the right answer, but you will also run out of time for all the other problems. So make sure you know those, okay? Now, by the way, speaking of, I do want to mention this. So we're covering 8.2. We're almost done with 8.2 today. We're going to cover 8.3 on Monday and 8.6 on Tuesday. We'll skip those other sections. We don't need to know those. And so we're ready for our last test, which means we'll have a review on review on Wednesday and the test on Thursday. And so we'll do the test on Thursday. So test 1 week from today, and the following week we will basically do a review. And so I think I have some old Salt Lake Community College final exams that I can probably give you guys to practice on. We'll probably do one of those next week. I'll probably introduce that after the test, so I don't want to mess up anything. But anyway, I just wanted to give you guys the calendar, kind of. So we'll have a test next week. So I guess that's a little earlier than normal, but we're done a little earlier than normal, and hopefully you guys can kick butt on the final. The finals are always tough, so we're going to spend a whole week on the final. All right. Okay, let's do one more problem. Finding the seating capacity in an amphitheater. Amphitheater. Okay. So the amphitheater has 30 rows, 30 seats. No, sorry, 50 seats. 50 seats on. No, it has 50 rows. 30 seats in row 1, 32 seats in row 2, 34 seats in row 3. What is the total number of seats? Okay. So once again, this is something you could list out all 50 rows and you could get the right answer. And if this is a test question, you're going to run out of time. So how would you guys do this one? Amanda's?
Would we use the first equation that s of n equals n divided by 2 times 2a plus n minus 1 times d?
Oh, the second equation here, this one here?
Yeah.
Yeah. So we can use that one. That's a good one. Okay. So S sub 50 essentially is what we're looking for, equals what? Go ahead and tally. Let's take it away.
Okay, so S sub 50 equals 50 divided by 2 times 2 of, is it 2 times 32 or 2 times 1?
Neither.
I don't know what a of 1 would be.
You do. When you said 32, you were looking at the wrong row.
34?
No, 30.
Oh, 30. Sorry, 30.
There we go. Yeah, your first row is 30. Okay. Plus, what's n minus 1?
Plus 49.
49 times?
Times 2.
2. Perfect. Okay. So 50 divided by 2 is 25 times 60 plus a 98, right?
Mm-hmm.
Okay. And if I just put an equal sign in front of that, it will give me the answer. And I've got 3,950. Okay. All right. So I think we're done a tad bit early. And I don't want to start the next section. How about that? Okay, so let's do you guys have any last comments or questions there?
So will our test next week, will it still be like 10 questions, but less, we like learn less content than we would have like having a test every 3 weeks?
Yeah, I think I still can come up with 10 questions. So yeah,
Okay.
we'll just go deeper into these sections, probably.
Okay.
And what sections did you say we were doing next week? We're skipping a few? Is that what you said?
So yeah, we're going to do 8.3 on Monday, which is geometric sequences. Then we're going to skip 8.4 and 8.5, and we will do 8.6, which is the binomial theorem. So 8.3 and 8.6 next week.
Okay.
Okay. Any other questions? Okay. Well, be sure to take your quiz on 8.2 on Monday, and we'll see you all on Monday. Stay healthy.
Thank you.
Thank you.